name's Miranda, and today I want to talk about two very different ways of teaching science, and I'm using two moon phases classrooms to help bring this to life. If you ever wondered why some science lessons really stick and others don't, these two examples will make it super clear. Let's start with the traditional approach to teaching science. In this type of classroom, the teacher leads the lesson by explaining concepts, showing diagrams, and giving students the information they need to learn. Students usually listen, take notes, memorize the facts and vocabulary, and then show what they've learned on a quiz or a test. We see this clearly in Miss Sheridan's class. She introduces moon phases by explaining them step by step and showing diagrams on the board. Students answer a few questions, then work in groups using models like styrofoam balls or flashlights. While it's hands-on, the activity is still very structured. Each group is assigned a phase and they follow the diagram to recreate it. The focus is on learning the correct names, the positions, so students are ready for a quiz the next day. Now let's talk about inquiry-based science, because this is where things get really exciting. Inquiry-based instruction flips the classroom from teacher-centered to student-centered. Instead of giving students the answers, the teacher guides them as they explore, ask questions, and figure things out for themselves. In Miss Lee's classroom, students spend weeks observing the moon and recording what they've seen. They ask big questions. They ask, why does the moon change shape? And then they work together and test their ideas. Students use models, talk through their thinking, and even disagree with each other in a good way. The teacher supports the process, but the students are doing the thinking. This kind of learning sticks because students discover the concept instead of memorizing it. Research shows that students learn science best when they are actively involved. Hands-on investigations, discussions, modeling, and explaining ideas all help students understand concepts more deeply. These strategies also support students with different learning needs, including students with disabilities, because they allow multiple ways to participate and show understanding. When students can talk, move, model, and explain, science becomes more accessible and meaningful to them. Inquiry-based teaching is grounded in the idea that students build knowledge through experiences. Instead of being told what to think, students test ideas, they reflect, adjust their understanding. In Miss Lee's classroom, students didn't just learn the names of the moon phases, they understood why the moon changes shape. That's the power of constructivism. When you compare the two classrooms, the biggest difference is student ownership. In traditional classrooms, students are following discussions, memorizing information. In the inquiry-based classroom, students are problem solvers, collaborators, and thinkers. Inquiry-based instruction creates deeper understanding and keeps students engaged, even though it takes a little more time. Inquiry-based science also supports inclusive and culturally responsive teaching. Students are encouraged to share ideas, learn from each other, and bring their own perspectives into the lesson. Teachers are more likely to recognize students' strengths and respond to the different learning styles. When students feel heard and valued, they are more confident and engaged in learning science. As a future possible science teacher, I want my classroom to be a place where students feel comfortable asking questions and exploring ideas, and I plan to use inquiry and discovery by giving students time to observe, investigate, and talk through thinking before jumping to explanations. I want my students to feel like small scientists, not just test takers. So, thanks for listening. See you later.